See, here we get the second derivative. You don't have to find it, we get it here. And the graph has exactly one point of inflection, which is this point here, Q. And we should find the x coordinate. And we have the answer here. So, and of course, if you want to find the point of inflection, then we have to find out when the second derivative is equals to 0. And the second derivative here is a fraction. And if a fraction is equals to 0, then the denominator has to be equal to 0. So we solve this equation. Then we have to get this by itself on the left hand side. So first of all, I just move over the number 3 here, change sign, then I divide by 2. So I get 3 over 2. And then, as I showed in the last video, to solve an equation with ln, we have to take e to the power 2 like this. And e to the power of ln to p is equals to p. So we get this answer here and divide by 5, or similar, we can multiply by 1 over 5, then this disappears, and I get 1 over 5 times e to the power of 3 over 2. So that is the x coordinate of the point Q. So that's fine. Then we have done this, and then exercise 9D, we should find an area here. And the area here R is then equals to the definite integral of this function. This is f of x, right? From a to b. And the function, if you remember that, the function is ln 5x divided by k times x. That was our function. And the limits here are the x coordinate of p, and the x coordinate of p was e over 5, if you remember that from exercise B, wasn't it? And from exercise and the upper limit is the x coordinate q, which is 1 over 5 times e to the power of 3 over 2. So if I manage to calculate this messy thing here, I would find r. No. But let's do this first. And then the task is to find k. And we know that this should be equal to the number 3. But let's concentrate on this first. Try and calculate this. And then, sorry, not 3e, but 3. Then I should find what k must be if this is equals to 3. Okay. So the first thing here, we have to find the integral of this. And that's a pretty complicated integral. So let's just concentrate on this. Just forget about the limits for now. And just find the indefinite integral of this thing here. And we get a hint here, which says that we should use substitution with u equals to ln 5x. And when we use substitution, we have to find the derivative of this. And the derivative of this, we actually show that in exercise A. That was actually 1 over x, right? I used, if I use the chain rule, I get ln to u is 1 over u, but I have to multiply with the derivative of the core, which is 5. So we just get 1 over x. And then I have to isolate dx here, get dx by itself. I first have to multiply by dx to get it away from the denominator. And then dx, of course, disappears here, right? If I multiply with dx here, and I get du is equals to 1 over x times dx. Then I have to get dx by itself, get rid of this, and then I just multiply by x on each side. And then we see that dx is all by itself on this side. 1 times dx is dx. And on the other side, we get x times du. And then, remember, when I have dx by itself, I can now substitute. So I get the integral of ln 5x, which I substitute with u, divided by k times x, multiplied by dx, but dx is the same as x du. And then, not the easiest task, this one. Then I can reduce x against x, and I get u over k du. And remember, k is just a number. Nothing scary thing, it's just a number. So to make it even easier here, I can see that this thing here I can write like this, right? If I multiply y in the denominator, I will get this expression. So then it's easy to see that 1 over k is just a constant. So I just keep my constant 1 over k, and then I find the integral of u, and the integral of u is 1 over 2 times u to the power of 2. Right? The integral of x is 1/2 x squared. So there we have the integral here. And then I can write numerator times nominator, denominator times denominator, and now I can change back. U was ln to 5x. That was the core u, right? Plus c. So there we have the integral of this f of x. Is the integral of f of x, right? So my task here is to actually calculate this messy thing here. But to calculate definite integral, I first have to find the integral of this, and then if I now go from here to here, so you need to find the antiderivative, and the antiderivative, as I just showed here, was 1 over 2k times u, which was ln to 5x squared, and actually plus c. We don't need plus c, and the limits are like this messy stuff here. And we still have a lot of calculations to do. And I can't remember how many marks it is. 7 marks. Okay, so I have 7 minutes, and I'm on 6:45. But I did the exercise. I did exercise C as well, and I've talked way too much, so that's why it's taking so much time. But let's now put in the upper limit first. Then we get ln to 5. I really need a bracket here. 5 times 1 over 5 times e to the power of 3 over 2 squared. That's correct, right? Minus 1 over 2k times ln to 5 times e over 5. We need a bracket here. Square. This is fun. Okay, and then what will this be? This will then be 1 over 2 times k times, and we can reduce here, so we get ln to e over 3 over 2 squared minus 1 over 2k times 5 against 5, ln to e squared, and we get 1 over 2k times an ln. Remember, ln to e to the power of p is equals to p. That goes from the definition of ln, right? So ln to e over 3 over 2 is actually the number 3 over 2. Minus 1 over 2k times ln to e, that is 1, so 1 squared. And still fun. Remember that. 9 over 4 minus 1 over 2k, right? Here I have something. We could actually factorize here. We could do a lot of things, but well, should we? Yeah, we can multiply. We can do it this a lot of ways. I just multiply here, and minus 1 over 2k. So this is how far I'm coming. I can make it even simpler. But if you remember the task was to find k such that the area, this is the area, right? And the area should be equals to 3. We have to solve this equation here. And we have an equation with fractions. We don't like fractions in equations, so I just multiply with a common denominator here, and the common denominator is 8k. I can multiply by 8k, okay? Then this will go away, and I will get k against k here, and get 8 divided by 2, which is 4, and here I get 24k. So I get 5 is equals to 24k, and then just divide by 24, and I get 5 over 24. And it all disappeared. There it is. And that's the answer. No problem, right? So the answer on 9D is k is equals to 5 over 24. And that was 10 minutes.